going to investigate a little bit to do with energy skate park simulation. I've got it opened up already over here, but that's a link to it. I'll make a video here as well and maybe make a few notes. So here it is. Do I have it open? No, I'll just load that up. So we did look at the intro, and let's just turn on some of these features. The grid's quite useful because we can see that it gets we can basically always see that it gets to the same place every time. So, and if we look at the bar graph, we can see that we do have a little bit of thermal, but that might be because I dropped him on the floor temporarily. When I dropped him on the floor, then it produced a little bit of thermal energy. But other than that, the kinetic is transferring into potential. Now, potential is gravitational potential. So we've learnt about gravitational. Some people refer to it as potential energy. It's not the only type of potential energy, but when it says potential, it means gravitational. So we've got kinetic changing into potential energy or gravitational energy. Whenever he's high up in the air, he's got lots of potential or gravitational energy. And whenever he's low down, he's got no potential energy. And if we click on the speed, we can see that, no surprise, as he falls down, he gets faster and faster. As he goes back up again, he gets slower and slower. Easier to see if I put it on slow motion. He gets faster and faster. Maximum speed at the bottom, slowest speed at the top. In fact, just before he changes direction, he reaches the speed of 0. And so that means the kinetic energy will be 0. I'll have maximum potential energy. So it's changing back and forth, but it's changing gradually. And that's a key point to realize about this. Now, clearly, we should be producing. He's not in real life. He wouldn't go like this forever. So something's missing, and that is friction. So we can investigate friction over here. So we can pick up this again, and let's put all the features on grid, bar graph, and speed. We'll look at pie chart in a moment, and drop it. Now you can see as he moves down, thermal energy is being produced. The thermal energy increases the most when he's moving at maximum speed. When things are moving quickly, they produce a lot of friction, and so a lot of thermal energy is produced. Eventually, he will come to a stop. And when he comes to a stop, the thermal energy is pretty much the same as the total energy. So the total energy always stays the same, and the reason for that is because energy cannot be created or destroyed. So I can turn this friction down on this feature, and let's put it on slow motion this time. Lift him all the way up to the top. I'll put it all the way down to none. I'll put the friction down to none. If I let go now, just like before, we've seen exactly. We know what's going to happen because it was exactly the same as before. Maximum speed at the bottom, 0 speed at the top, maximum potential energy or gravitational energy at the top, 0 gravitational energy at the bottom, and maximum kinetic energy at the top. If we look at a pie chart, we can see that it's got all complete gravitational energy at the top, and then complete kinetic energy at the bottom. Okay, so really that's the main thing we need to get from this here. You do actually have a few other features here, so you can play around with this ramp, and we can see how it gets to a maximum speed as he gets to the bottom, and then races off at that same speed. Okay, because there's 0 friction. If there was some friction, what would happen? Well, it's interesting. I'll see what that happens. So he gets to maximum speed, and as he goes, notice the speed is reducing gradually because there is some friction. Okay, so that's an interesting experiment there. We've also got this situation. Let's turn friction down to 0, and it goes down and back up again. It's still going to reach the same height as before because it was still gravitational, turning into kinetic, back into gravitational, back into kinetic, back into gravitational. So it's still going to reach the same speed. You also got a feature of a playground here, which some people quite like. So you can make your own little ramp. I guess these connect together like that, and yeah, we can sort of experiment and see what's going to happen there. Not sure what this feature does. Okay. All right, so I'm gonna stop there, and I'll save that video and put that inside your board.